There is a small river in front of your house. In the river, there is a round stone. Whenever the flood season arrives, the viscous effect of the water flow on the stone's surface will wash the stone away. You suddenly have an idea. You went home and did an experiment. You pointed a car wash water gun at the edge of an axle disc. Due to the viscous effect, it will start to spin. You felt that it was still not enough. It was spinning too slowly. So you put a shell-shaped sleeve around it. Now you don't spray water inside. You introduce steam inside. The steam will enter from the tangential direction of the shell, passing through the disc, then discharge from the vertical direction at the center of the shell. Initially, if the steam speed is very low, the viscous force between it and the disc is very weak. The disc can hardly rotate, but as the steam speed increases, the viscous force increases sharply. The disc begins to spin. You are very clear. The key here is that, in order to maintain the rotational state, the steam particles need centripetal force. At the same speed, the closer the steam particles are to the center, the greater the centripetal force required. Therefore, the steam particles always tend to escape from the center area. However, the outlet of the shell happens to be at the center, so these steam particles cannot escape and are discharged. In this process, you find that the greater the speed of the disc, the farther the steam particles are from the center, so you immediately have the idea. This spiral shape greatly increases the contact area between the steam and the disc, thereby increasing the viscous force between the two. At this point, you want to optimize it again, so you introduce an important concept in fluid dynamics that you learned in university, that is the boundary layer of flow. What does this mean? Let me give you an example. On the surface of the disc, a layer of fixed steam particles will form, called the boundary layer, and the upper steam particles will drag the fixed layer, but the fixed layer hardly moves. Therefore, a portion of the energy is lost to the fixed layer. This phenomenon in fluid dynamics is called viscosity. Based on this principle, you designed an amazing solution. Increase the number of discs to 3. This way, each disc surface will form a boundary layer, and the area between the two boundary layers is the free-flowing space for the fluid. To improve efficiency, you also reduce the distance between the discs, maximizing the reduction of the free-flowing space. Thus, the energy of the steam particles can be maximally transferred to the disc. Then you put it into practice. The good news is it spins very fast. It reached 35,000 revolutions per minute. The bad news is the disc's strength couldn't withstand the huge centrifugal force and bent, so you had to reduce the speed to below 10,000 revolutions per minute. At this point, you have successfully invented a bladeless turbine. Although it can't replace the steam engine, but making it a very efficient pump is still not a big problem.